Welcome everyone to another edition of the Data on Kubernetes community. I actually have to check to see which number meetup we're on. I believe we're on number meetup 42. All right. We've been doing a lot of meetups. We have a lot of meetups coming up as well in the next few weeks. As usual, if this is your first time in the community, Gorka, can we get the links on the screen? Just a quick reminder, we are on LinkedIn, we are on Slack, we are on Twitter. We are almost at 1,000 followers on LinkedIn, so that's very exciting. In terms of other numbers that we can mention, we have a very important event that's coming up on May 3rd. We'll be participating in KubeCon on Monday in a co-located event exclusively for the Data on Kubernetes community. Gorka, if you can show the CNCF website first. If folks want to register, all you got to do, if you're already signed up for KubeCon, it's pretty easy. Just go to the CNCF co-located events page. You can see all the stuff there. And there you will also find a link to the schedule. Tickets are totally free. All right. You don't have to pay anything. It's 100% complimentary. So yeah. And if you don't have a ticket to KubeCon and you would like to attend, all you got to do is reach out, contact me. We'll find a way to get you in there. All right. But as some of you may know or may not know, we are now as a community integrated into the CNCF ecosystem. Yes. So we also have a page there on the CNCF community website. But then Gorka, can you go over to the schedule page, please? Thank you. So if we scroll down on the schedule page, you'll see we still have a call for papers that's open. All right. So we are looking for end user talks. JY, if you'd like to give an end user talk, you're more than welcome to. You're more than welcome to submit a CFP. So we do have, like I said, a provisional schedule that's up right now. But there's going to be more stuff that's going to be added there this week and also next week, right? So some more end user talks from some different companies, also some lightning talks as well too from different folks from different places. But anyway, that event will be, like I said, on May 3rd from 10 until 5 p.m. In the time zone that JY and I are located, which is not the most frequently used time zone for a lot of events. So it's nice to kind of not have to stay up really, really late or wake up really, really early. All right. So like I said, there will be more news coming out about that soon. Cool. Gorka, we can stop sharing our screen. So as I said, this is meetup number 42. We have had conversations about Elastic. We've had conversations about Kafka. I think this will be, though, the first meetup, at least the first one that I'm doing. There's going to be more in depth about Spark, right? So, JY, can you just introduce yourself, explain who you are, where you are, how you got into this whole world? As a reminder for all the folks out there as well, too, in the audience, you can feel free to ask questions whenever you want. We will get to them in an orderly fashion. Also, you can jump in our Slack. JY is very attentive, so if you have questions that you want to ask him there, you can totally do that. But anyway, introduce yourself.
Yeah, absolutely. Hi, everyone. Thank you so much for having me in this meetup. So I'm JY. I'm a software engineer by trade. I worked for a few years at Databricks. I was leading their Spark infrastructure team. I was lucky to join Databricks when it was still a pretty small startup, and then saw it massively scale. And 3 years ago, I left and started Data Mechanics. We are, so I'm one of the co-founder. I actually focus more on sales and marketing now, but still, it's to build a data platform tool for data engineers. It's very technical. So, I'm having fun. I'm staying really technical at the same time. And yeah, Data Mechanics, we're a Y Combinator backed startup, and we are building a cloud native Spark platform. So it's basically a managed Spark on Kubernetes platform.
Very, very good. And it's interesting as well, too, because yesterday, actually, in the meetup that we had in Spanish, we were talking about transition of folks that are going from the big data technology stack, folks that may have experience with Spark, Storm, Hadoop, all the big data technologies that would be there. And now moving into this Kubernetes space. In your particular case, JY, when did you first interact with Kubernetes? What was the first time that you heard about it or started using it?
Yeah, as a software engineer at Databricks, originally we didn't use Kubernetes. We were using pretty much, bare bone JVM stack running on VMs, and we gradually started using Kubernetes not for Spark, but for our internal services, and that was great. And then we had some hackathon at Databricks every quarter, and there was a hackathon where we started running Spark on Kubernetes because that was something that was starting to be possible from the open source community, but we didn't do it within the Databricks product. And then I was a big advocate for it. But up until now, up until maybe very recently, Databricks didn't run Spark on Kubernetes. It has their own custom cluster manager.
Okay. And in that case as well, because one of the things that we talk about a lot of times is the challenge, not just from a technological perspective, but from a cultural or mindset perspective. What advice would you give to folks out there that might have experience in the big data world? They might have experience with these technologies. They're getting in, we always say there's going to be trial and error. You've got to be patient. Don't be afraid to ask for help. In your experience, what would you recommend?
Yeah. I don't think every data team should necessarily become Kubernetes experts, because it's really a beast. When first I was introduced to Kubernetes, I was like, whoa, all these concepts. But with some patience and some easy guides to get started, you start realizing that it's just about running containerized applications and that you don't necessarily need to go really deep to be a Kubernetes user. And yeah, I would just recommend to follow some tutorial and start with the basic things, just like understand, what's a container, how to build a Docker image, how to run Spark in the Docker image, and just that is great start.
Yeah, I think it's a good point, though, is that some people might feel like they have to learn absolutely everything when they're just simply not the case. And so that's the thing. Focus on the things that are actually going to be practical, that are going to deliver value in your use case for your customers. That's kind of what we're here to hear about today in terms of the case of data mechanics. That being said, if you want to jump right into your presentation, go for it. Just a reminder for folks that may have arrived a little bit late, feel free to ask questions in the chat. We will get to them accordingly. If we're not able to get to them, all of them in the hour that we have right now, we can definitely continue the conversation in Slack. But anyway, JY, take it away.
Yeah, sounds great. I'll start sharing my screen. As I do so, I may not see the chat, so will you ping me, Bart?
No problem. I'll jump right in. Yeah.
Sounds great. So let's see. I think you guys will soon see the slides. So, Spark on Kubernetes is now generally available. This happened recently last month with Spark 3.1 release. And this talk is first about, why. So, what is Spark on Kubernetes? What's the benefit? And then help you potentially adopt it, migrate to it. Thank you so much, for having me. So indeed, I'm one of the co-founders at Data Mechanics. I previously worked at Databricks, and on the right-hand side, this is a picture we took. I think it was in February. It was awesome weather with the team at Data Mechanics. Our team is based in Europe, though we're also hiring people in the US. In fact, we have an open role right now for solutions architect in the US. If you're interested, we can chat. You can find the job description on our website.
Very good. Sorry, just to stop you right there. 2 questions. First of all, where was that picture taken?
Yes, it's in Normandy, northern France.
Beautiful, very beautiful. I went to Normandy many, many years ago. And we already have another question. This is more technically focused, all right? This is from Jeff Carpenter. Jeff asked, what kind of challenges did you run into getting Spark to run in Docker? Were any changes to Spark required in order to make it work as expected?
Yeah, that's a great question. And it's a topic I'll touch on a little bit at some point.
Jeff also mentioned that in his comment. He knows that it might come later. But anyway, if you want to touch on it now, great. If not, we can get to it later.
So one announcement that we actually just made, I think, I'm sure we made it yesterday, is that we now provide base Docker images for Spark. We didn't need to make really changes to Spark itself, because in fact you can download the Spark Docker image from the Spark official website. But then the hard part was more about actually talking to the popular data sources, whether it's an object store, so S3, GCS, Azure Data Lake, Hadoop, Delta Lake, Snowflake, others. And it's not just Spark that you need to have in the Docker image, but it's you may need Python if you're going to be using PySpark, and that's what most people use. You will need Java and Scala regardless, because that's what Spark is based on. And all these libraries, they have recursive dependencies that could clash with each other. So this was my biggest problem, getting started with running Spark in Docker. It's the same problem actually using Spark on YARN. In fact, Docker just forces you to build an image, and so to to treat the problem once and for all. But then once the image is built and it's working, you know that no one is going to upgrade some dependency under you and broke your production pipeline without you knowing. So overall, Docker is great. It's a big benefit, but indeed, this was one of the challenge, and we just publicly released a set of optimized Docker images on our Docker Hub. So yeah, I took a little fast forward, but anyway, I think it's fine because it's not exactly related to Kubernetes. I mean, you could be using Spark on Docker without even Kubernetes. So I'm glad this question came up early.
Very good. Thank you, Jeff.
Let's see. Moving back maybe to where we were, I think I'm done with the personal presentation. Just quick presentation of the company, though this is not a marketing talk, not trying to sell you data mechanics, but we are an alternative to the big guys, Databricks, my former company, EMR, Data Proc. To compete with the big guys, we have to focus on one thing and do it really 10x better. And that one thing is running Spark on Kubernetes and focusing on data engineering workloads. So, typically large scale ETL pipelines and making sure they are stable, performant, cost-effective. So making Spark developer-friendly and cost-effective is really what we focus on as a company, and we are available on AWS, GCP, and Azure. So now let's go over the high-level agenda of what I'd like to cover. First, Spark on Kubernetes. What is it? Then why is that interesting? And maybe go over, a case study of a company who migrated from EMR to Spark on Kubernetes and what that migration looked like. And then we'll go about more concrete technical tips to help you migrate to Spark on Kubernetes. Some of them will be related to infrastructure management, really managing the Kubernetes cluster. Some of them more on the application side. So Docker images, we talked about that, but also monitoring. And then I'll talk about the most recent improvements that came in March. And there's a fourth item, but this will depend on time. I might do a quick demo to illustrate some points. And just like Bart says, feel free to interrupt me as we go through this. So first, before talking about Spark on Kubernetes, just a few words on Spark. It's the #1 analytics engine for big data. So what people like about Spark is first that it can process very large volumes of data really fast. Why? Because it's distributed. Your code is going to be run in parallel across many machines. Second, it's pretty easy to use Spark because it has these high-level APIs in languages that people know, like Python, SQL, and Scala and Java may be a little less common, but still very popular and performant. And lastly, it's versatile. So if you have a very specific use case that's more about search, there might be a separate tool. If you have a use case about only streaming, there might be a separate tool. But if you want a general purpose distributed language that can do anything from business intelligence to machine learning and data science to ETL and real-time streaming, then Spark is a great Swiss Army knife. And particularly, it will, on the ETL side, if you have very large volumes of data to process. So you start using Spark when your data set are over 100 gigabytes, then it's the tool for you.
We got a question.
Yeah.
How is this? And this is a great question. So thank you, whoever asked this. How is Spark different from Hadoop?
Yeah, great question. So Spark is really the evolution from Hadoop in the sense that they're both distributed computing languages, and Spark was, when Spark was written, there was only Hadoop, and Spark was written to fix a lot of the problems of Hadoop. So what improvements did we have? In Hadoop, you had the MapReduce framework. So first you had to think of your big data application as a succession of map and reduce phase. I'll not go into the detail of what they mean, but it was a constraint. You couldn't just say to your in your code, oh, give me this average or give me this aggregate. You have to formulate this as a succession of map and reduce. Spark came up with much higher level APIs. In fact, it just reports plain SQL, and then it figures out how to distribute it. So this is at the API level. Now, if you talk more about the implementation, the execution, Spark relies on memory, so caching data in memory rather than always writing to disk a lot. And it relies on doing the work where the data is. So avoiding to move the data around, we call it shuffle, as much as possible, because these data transfers are slow. So because of that, Spark is 100x faster than Hadoop, and that's why today very few people are writing new Hadoop pipelines. Hadoop still exists, but it's mostly very few people write new Hadoop code.
Perfect.
I hope.
I think we're good. Yeah.
So now that we talked about Spark and Hadoop, where does Kubernetes fit? So I explained that Spark will run your code in parallel across many machines, but to manage these machines, these containers, you need what's called a cluster manager. Spark is not a cluster manager. Well, actually, there is a standalone mode where Spark kind of does cluster management, but it's pretty limited. Hadoop YARN is the most common cluster manager used today. And you might be surprised, oh, it's Hadoop again. But here we're not talking about Hadoop as the execution engine. We're talking about YARN, which is the resource manager or cluster manager of Hadoop. And today, most people still run Spark on YARN. The big commercial platforms like EMR and Proc run Spark on YARN. And now Kubernetes is the new kid in the game, and beta support started in 2018 with Spark 2.3. So what does it look like to run a Spark application on Kubernetes? Well, we talk about running natively on Kubernetes because first, when you submit your Spark application, you can talk directly to the Kubernetes API, the Kubernetes master, which understands your requests, and also because after you submit, so you make this call, you say, oh, run this application, it's going to start a driver pod, basically a driver container on the Kubernetes cluster. And then the driver container and the Kubernetes master, they're going to be talking with each other. Driver is going to say, oh, I need 3 executor pods, and then Kubernetes is going to schedule, so it's going to start these 3 containers, and then it's going to notify the driver, oh, they're ready. And when they're ready, Spark is going to start running tasks on them. So just to explain a little bit the high-level framework for running Spark, you submit code like a simple Python file where you have some high-level function. Oh, I want the average of this. I want to drop duplicates in this data set and so on. And then Spark is going to divide your code into jobs, stages, and tasks. And a task is the smallest unit of work, and a task gets run on actual executors. So the driver is the brain, the executor, they do the real work. Yeah, one of the difference between Kubernetes and YARN is that on a Kubernetes cluster, you can run isolated Dockerized applications. So you have control over the Docker image, and the Docker image contains the Spark distribution itself. That's not possible on YARN. On YARN, you have a global Spark version. And then you can also run very different workloads, whether they're interactive, whether they're batch, whether they're streaming. And the Kube cluster can be backed by very different infrastructure. Kubernetes is available in the cloud, on-premise, and then once you choose a cloud provider or a certain setup, you could be using different instance types underneath. You could be using Spot and on-demand. So really, Kubernetes is a great abstraction where on a single cluster, you can do anything you want without with a clearer separation of concern. Maybe this slide maybe I'll still mention it. So there are 2 ways you can run Spark on Kubernetes. One of them is using Spark Submit, which is the open source way included in Spark distribution itself. But then the other way is using the Spark on Kubernetes operator, which was open source by Google, but it works on top of any Spark platform. And particularly if you if you know a little bit Kubernetes, you will like the Spark on Kubernetes operator much better because it lets you manage a Spark application just like a regular Kubernetes object. So you can describe it, you can start it by specifying a YAML file. There's also tooling to read its logs, to kill it, to restart it, schedule it, and so on. There's also some syntactic sugar to make some things simpler. So honestly, I would really recommend it. There's a long list of companies using it, and that's not a wonder. The only downside is, it is one more, dependency or thing to maintain, but I think it's worth it. It will make your life much simpler. I think we went over the core concepts of what it means to run Spark on Kubernetes. Now let's compare Kubernetes with YARN, the main alternative, and explain the pros and cons of each.
One thing real quick. Sorry, JY. We got a question from Tim. Tim, amazing community member. Tim's question is, how does Data Mechanics manage Spark compare versus Google Dataflow or Data Proc?
Yeah. Let's see. I think I may have some slides that cover that. So Dataflow is for running Beam, but I think Dataproc, which is not Spark, but I think Dataproc is really the right comparison. So first, Dataproc, their main offering runs Spark on YARN. They also have a beta support for Kubernetes, but you lose a lot of the features of Dataproc. In general, how do we compare? I think we make Spark a lot more developer friendly and cost effective. I didn't want to cover too much the platform itself, but let's just say that first we have some integrations. I think the biggest differences will be that we will automatically scale the cluster up and down. We will automatically tune a bunch of configurations for your pipelines, like the size of the containers, like the type of instance to use, like the Spark configurations around the number of partitions, around shuffle, and so on. And that will give you a much simpler developer experience, but also more performant, so faster, more stable, and cheaper pipelines. So TradeLab is an example customer that we migrated over from Dataproc, and they were very happy with having less infrastructure management to do, and also with the cost savings we generated. We reduced their cost by half. Did I see more questions, Bart?
Let's see. Yeah, so we've got. Oh, now we're getting man, you're getting people really excited about this. So a question that we got from Ashish is, I'm using Spark operator on Kubernetes and Spark 3.0.2 for my Spark workloads. My question is on support for dynamic allocation and shuffle tracking. You may need to stop sharing your screen to look at the chat just because he's got this API version. Yeah, kind of explained there. He says above is a snippet from a Kubernetes deployment. Yeah.
Here we go. Ashish. Yeah. Spec, I see. Above is a snippet from Kubernetes deployment file. Please elaborate on support for dynamic allocation and shuffle tracking. Yes, I do have slides about that. I wonder if we should still kind of follow the agenda, or
let's follow the agenda. And the thing is, we've got all these questions written down in the chat. Thank you for asking the question, Ashish. And the thing is, if we don't get to it, just remind us, or like I said, that we can continue later on in Slack. But I think for right now, just keep going. Yeah, look, no, but this is good. We're getting some action. This is good. Anyway, keep going. You're good, JY.
Yeah, sounds great. But yeah, that's a great question. And Spark and dynamic allocation is super important. So I'll come back to it and I'll mention it. So I just wanted to stress the big differences between running Spark on Kubernetes versus YARN. And one of them is just that you benefit of containerization. So you control the Docker image that is going to run on the Kubernetes cluster. And in fact, this Docker image, you can also use it to run Spark locally on your laptop, maybe while you're doing development and testing. That's super popular. And then in the Docker image, I mentioned this earlier, but you have the Spark distribution itself, you have Hadoop, Java, Scala, Python, and all the data connectors you want. And once the image is built, you're going to get reliable execution. So there isn't someone who's going to, I don't know, change, bump up the Scala version used by Yarn and then potentially break your application. And Docker, building a Docker image sounds a little heavy, but honestly, first, it can't be fast to build it locally because Docker caches previous layers, or you could have a CI/CD pipeline that automatically build a new image remotely once you make a PR to a repo, for example. And hopefully in the demo I'll show you, but you can have a really fast iteration cycle while using Spark on Docker. And the consequence, I mentioned it, but since the Docker image contains everything, honestly, the Spark applications are fully isolated. In fact, obviously you could be running Spark and non-Spark application on the same cluster. And you get really fast startup time. So on Yarn, there is a lot of overhead because you install a lot of JVM agents run by Yarn, and that takes a while. You often run long init scripts because that's how people install dependencies and so on. On Kubernetes, you just download the container, start it, and if a node is available and ready, it starts in seconds. If you need to get a new node from Amazon or GCP first, then it takes another 1 or 2 minutes, but honestly, it's fast. So, the benefit there is that you get the cost efficiency of being of a shared infrastructure, okay, because you have a single Kubernetes cluster and you can very quickly reallocate capacity between different workloads, and you get the full isolation of having, very separate. Here separate Docker containers, but on the Yarn side, you have to make a trade-off. Either you have a single Yarn cluster, which is maybe cost-effective, but which has isolation problems, or you have many independent clusters, but then they take 10 minutes to set up, and you don't get any resource sharing. So it gives you the best of both worlds. This trade-off between single tenant ephemeral clusters or long running shared clusters doesn't exist anymore. The last benefit is obviously there's a big ecosystem around Kubernetes. We can see it, just the fact obviously the CNCF and the community, the Data on Kubernetes community illustrates this again. Kubernetes is a cloud provider abstraction, so it's easier to port your application from a cloud to another. There are lots of tools, whether it's about CI/CD logging, networking, security, a lot more things. And that means that you're not going to have two separate stacks, one used by the software engineer and your web application, and the other one used by big data. Everyone's going to be using the same tools, and you're going to get a lot of features for free. Last thing I want to mention on this first section is just an example of what you could expect if you're migrating from a Yarn platform like EMR to Spark on Kubernetes like Data Mechanics. And this is a customer based in the US, and they're a Spark-based data integration platform themselves. So Spark is really core to what they do. It's their core product basically. They used to run on EMR, and their main problem was that they had too much infrastructure to manage, and they also felt that they were really paying a lot of costs for the value they were getting. On top of that, applications started slowly, which sucked because they run Spark application for their users. So you have a user waiting for the application to start in their product. And they were stuck with Spark 2.3 because they couldn't gradually upgrade. So how did we help? Application startup time went from 40 seconds to 20 seconds. Stuck with Spark 2.3, well, the fact that now it's containerized, they were able to gradually upgrade it. And now, in fact, they're using 3.0 across the batch. And the cost, I mean, the fact that they have a single Kubernetes cluster, just that was huge. On top of this, we implemented a few optimizations at Data Mechanics around, automatically scaling the cluster with the right size, right sizing some Spark applications, having optimize committers to S3, these kind of things. But in the end, we reduced their Amazon cost by 2/3. So that's huge, and that's what we see with a lot of our customers. I'll be posting the slides afterwards on the Slack channel, and so you'll be able to follow the link if you have some follow-up questions, or obviously ask me.
Perfect.
Yeah, great. So now I wanted to go over really concrete technical tips for using Spark on Kubernetes. Were there some questions, Bart, or?
No, we're good. Keep going. You're good.
Sounds good. Yeah. So on the infrastructure management side first, I just want to explain a little bit how Kubernetes work, maybe though it's obvious for many of you here. On Kubernetes, you define node pools, which is basically a set of nodes, so virtual machines. And it's important that these node pools can automatically scale up and down. So that the Kubernetes cluster does not have a fixed size, but that if you're running in the cloud, it's great that it's auto-scaling, because as you, it will reduce your cloud cost, basically. You can be using different node pools using different instance types. Some of them can be on demand, other on spot, and then you can pretty much mix and match what happens on your Spark application. So, for example, you would say, "Oh, I want to put the Spark driver on an on-demand node," because on-demand node, they're not going to be preempted, they're not going to go away, and so that's where you want to put the Spark driver. But then you're going to say, my executors, I'm going to put them on spot, because if the executor goes away, it's okay, I can recover. It's very important to make sure that your node pool, they can downscale to a size of 0. We use the open source cluster autoscaler project for that. There are a few tricky things. I'll also link to a blog post that goes into more details. But overall, this works really well. One little tip that we implemented actually for Link, the customer I was mentioning earlier. Link, they didn't want to pay too much cost. No one wants, but at the same time, they wanted to guarantee that they had a small startup time. They wanted to make sure the Spark application started quickly in maybe 20, 30 seconds. So how can you balance the two? What we did is we did a little bit of over provisioning. So we made sure that the Kubernetes cluster always has at least 1 or 2 extra nodes ready. So how do you do that? You define pause pods. These are containers that basically are defined with Kubernetes, but they do nothing. And they have a low priority, such that when now a Spark application says, "Oh, I want 1 more executors," or to Kubernetes, well, Kubernetes is going to evict the pause pod, because you gave it a low priority, so it's fine, and use that room to start the Spark executor, and that's going to take seconds, if potentially less than 10. And then since Kubernetes still have this pause pod definition, well, it's going to scale up the cluster and add a node. So in the end, you end up with always maybe 1 extra node of over provisioning, and unless there's a very big burst of requests that come all at the same time, the applications will start quickly. We're now getting to the topic where there was a question, dynamic allocation. And so dynamic allocation works on Kubernetes since Spark 3.0 only, okay, not 2.4, through shuffle tracking. So what does that mean? There's some explanation to do here. So first, maybe shuffle. Shuffle are the phases in Spark where the data is shared, across executors. An example of when you need to do a shuffle is when you were reading data which was partitioned by a certain column. So maybe I don't know, you had some data which was partitioned by user ID. And then you ask for a group by, so you want to group the data by some other column, maybe by, I don't know, their age, and then you want to write the data this way. So it's not a group by, but it will be partitioned by, or maybe you need to compute some aggregations. Well, what Spark will need to do in such a scenario is to group all the data with the same key. And so it will need to send the data across executors. Okay, so maybe originally this is how the data was laid out, and then executor one is going to be asking for pieces of data that are on other executors. This is a very heavy process. It's very slow. So in general, we try to avoid shuffle. We try to lower the volume of data which is shuffled. And what we need to be careful is that shuffle files, they're very important. If you lose an executor, you realize that you don't have the full data anymore, and so you should never lose a shuffle file, because otherwise you're going to need to recompute it. So now to explain shuffle tracking. In Spark 3.0 and dynamic allocation, the only way to make dynamic allocation work is to enable this other config, which will tell the Spark driver to basically keep track of which executor is storing an active shuffle file. And if an executor is storing an active shuffle file, then this executor will not be killed. It will not be downscaled. Why? Because if you kill it, you are losing a precious file, and you will need to recompute it. So it's a constraint, because on YARN, instead of enabling shuffle tracking, you can enable a service called the external shuffle service, and the external shuffle service does not exist on Kubernetes due to pretty complex reasons about the security model of YARN and Kubernetes. It's not possible to implement the external shuffle service in the same way.
We do have a follow-up question, and JY, you probably want to look directly at the chat. Following up with the thing that was mentioned previously about shuffle tracking, saying that there is no mention of shuffle tracking after having gone to that link.
Okay, I see this link. So let's see. This is a link to Spark on Kubernetes operator. Yeah, that's interesting. I'm on the link that they shared, and indeed they just specify dynamic allocation. I'm not sure if potentially if you enable dynamic allocation, they would automatically add the shuffle tracking in the Spark conf. This is something you could check in the Spark UI, but they should. The Spark operator at the wait. Okay, the operator supports a limited form of dynamic resource allocation through the shuffle tracking introduced. Yeah, okay. No, that is what I said. It's through the shuffle tracking and enhancement. So you do need to enable the shuffle tracking, and so this is the config I mentioned. So maybe if it's not working for you, that's why, I think. Let's see. Let me go back to the chat. Yeah, yep. You do need to enable it. And Ashish, when we talk about Spark 3.1, we will go back to this topic, because there's a new improvement on Spark 3.1 where you could potentially run dynamic allocation without shuffle tracking again. But I'll cover it in a follow-up slide.
Awesome. Good stuff. And thank you for the questions.
Yeah, these are great questions. So yeah, overall, dynamic allocation is great. I really recommend it, particularly if you are using Spark in an interactive way. If you run Jupyter notebooks, and when you use notebooks, you tend to run it for 10 minutes and then take maybe an hour break because you go to a meeting. And there, it's really important that you clusters, application scales down and not waste the resources during that time. If you're running just I don't know, just ETL workloads, some of them can benefit from dynamic allocation. Some of them are fine with a fixed number of executors. If you have a fixed number of executor, well, then you need to kind of iterate and see what is the trade-off between having more executors, which may make the application run faster, but may still cost you a little more at the end of the day, or less executors. Let's see. Google slide. is refusing. Let me refresh.
All right, demo effect.
Yep. This isn't even a demo.
Demo.
This is the part that's supposed to be stable.
This is the Google Slides demo. It's a Google Slides demo. Yeah. That's okay. That's all good.
Here we go. Maybe I'll just reopen it. Here we go.
Yep.
So we covered the part about dynamic allocation, and then the next part was about talking about Docker images, but we already covered this early during a question, but I just want to mention again, yesterday we officially released a set of Docker images that we have built for anyone to use. You don't need to be a customer. You just use them and run Spark on Kubernetes yourself, or run Spark and Docker yourself. And the nice part about them is that we include all these data connectors and dependencies, and we have tested that they work. And I don't know, it may look simple to do this yourself, but it was actually a very long engineering effort, not only to build them once, but to be able to maintain them over time. So try them out, and I hope it'll be useful. And the last advice I wanted to give, if you want to run Spark on Kubernetes, is on the monitoring side. Obviously, you need good monitoring to have a good developer workflow, to troubleshoot issues, and so on. So what tools do you have to monitor Spark on Kubernetes? Some tools are general purpose, not specific to Spark, but they're pretty great. So some cloud providers like GKE provide one, or you have the Kubernetes dashboard, which is open source, and there are many other monitoring tools for Kubernetes. In general, they are going to give you some CPU usage, memory usage, disk usage, I/O usage per pod. The only issue with that is that you may have 100 executor pods, and so it's going to be hard for you to kind of get the high-level insights. So, what happens overall in my Spark application? The second problem is that they just give you a timestamp here. So if you want to correlate the timestamp with, this is the part of my application where I was reading data from S3, and this is the part of my application where I train a machine learning model, you're going to need to basically open up the Spark UI, open up the graph, and then go back and forth and match the timestamps. Everyone gets used to that bad UX, but honestly, it is bad. So how do we make? So that's one kind of tool. The other kind of tool is the Spark UI. This is open source, not specific to Spark and Kubernetes. You can while the app is running, it's accessible on a certain port. So you can port forward the driver pod on port 4040, and then open this, and you'll have access to the Spark UI. But yeah, I always felt that between the two, there's a bit of a gap, and even the Spark UI, it displays a lot of information, but it's hard to figure out what's the performance bottleneck. It's hard to know where to focus your attention. So for this reason, we worked on a free and cross-platform monitoring tool to complement the Spark UI. And our goal was to both show the Spark phases. So what I mean by that are the jobs and stages, so that you can understand the metrics and relate them to your code, and at the same time give you memory metrics and CPU metrics aligned on the same graph. So that's what we're showing here. Maybe I'll show.
We got another question from Tim. How does Spark on Kubernetes tie into the monitoring ecosystem with, for example, StatSD, FluentTD, etc.? He says that he's not that familiar with Spark or Spark metrics.
Yeah. In general, it ties well. There are many things you can do. You could be, you could obviously export service logs to FluentD and then to whatever system you want to use. You could also, there are also specific metrics that are exposed by Spark, and you could push them to Prometheus and then display them in Grafana, or you could be using commercial solutions. I don't know, Datadog, for example, both has node level metrics, pod level metrics, Spark metrics. This being said, overall, I feel like these solutions, there are a lot of things to set up. And one of the reasons why we develop Delight is to have a very simple monitoring tool that you can plug in, and that is Spark centric. So it's built specifically for Spark, and it will help you understand the performance bottleneck or the cause of instability of your apps based on Spark. Just to explain the architecture of Delight, there's an open source agent which runs in your Spark application. So, maybe on your Kubernetes cluster. And then there's a backend on our side, which we host. The agent will stream the metrics to our backend. They're encrypted using a key that you need to create in the dashboard. And then the dashboard is served on the web app, delight.datamechanics.co. These logs that we send, these are not your application logs, which could contain your own logs that you write and could be kind of sensitive. These are Spark event logs, which are more metadata about your Spark application and non-sensitive. And we will automatically delete them. So we're not, trying to steal, monetize or send it to third party. No, we don't. It's just for you to use, and after 30 days, they're deleted. And then this is an example of Delight, what the screen looks like. Our goal was to make it obvious when you suffer from a specific issue. If I look at this application, which ran in 4 hours, 20 minutes, I can tell that a big portion of the job was spent doing shuffle. And you can see all this purple area, this is shuffle. And in fact, you can see that there's a stage which was retried multiple times because it was failing. If you looked at the Spark UI, it was not obvious that it was due to shuffle, not obvious at all. And with this customer, Jellyfish, here was obvious. What we did is we attached local SSDs. So these are disks that have a really high bandwidth, and they can make the performance of shuffle much better, because during shuffle, you first write the data to disk and then send it across the network. And yeah, the same application which used to run in 4 hours 20 now runs in 25 minutes, and you see the shuffle area almost disappeared. So these are the kind of insights that you can get from Delight.
All right, we got another question from Jeff. The idea of pause containers seems like a workaround. Is there some functionality that is missing from the Kubernetes scheduler?
Yeah, I do agree. It feels a bit like a workaround. It's not. I don't think it's a missing feature from the scheduler, but more from the cluster autoscaler, which is an open source project that can automatically provision new instances from you. And indeed, it would be nice if we could just say, always over provision this number of CPU and memory and so on. But yeah, this being said, if you look at this open source project, that's how they tell you to do it. And the definitions of pause pods are pretty small. So I do agree, it feels a bit like a hack, but it's a pretty robust hack at this point, and I'm not sure if they're planning to add this in a native way. Was there another question?
Nope, we're good. We're good.
Okay.
Yep.
So I think we covered Delight. So by the way, Delight is, you can get started. I have not announced it yet, but that's it. We just made it open to the world. We will officially release it with a blog post and Hacker News launch tomorrow. So if you want to try it out, go ahead. I'll send the link afterwards, but there are installation steps, whether you're using Spark Submit, whether you're using Spark on Kubernetes Operator. It also works on top of EMR, Proc, Databricks, Livy. Many different platforms are supported, and we hope it'll be useful. All right, so let's see. Okay, I think we're doing okay on time. I don't think I'll have time for a demo, but we can talk just a little bit about the most recent features added to Spark on Kubernetes last month. So Spark on Kubernetes started in 2018 with initial support in 2.3, but honestly, 2.3 was super buggy and it was missing critical features. In November, 2.4 was much better. Typically, you had support for PySpark and R. You also had support for mounting volumes, disks, which was not possible earlier. And then 3.0, a year and a half later, honestly, is amazing compared to 2.4 again in terms of the performance improvements and the overall stability of Kubernetes. Dynamic allocation, which we talked about through shuffle tracking. And then last month, Spark 3.1 came out and Spark Kubernetes was officially declared generally available. Because before that, there was a note in documentation that it was not production ready and that you can experiment with it, but be careful. And now they officially recognize that, hundreds of companies have been using it in production, probably actually thousands. We had some new features with Spark 3.1, and I'll go over them now. The first one, and this is going to tie back again to the conversation we had about dynamic allocation, is called better handling for node shutdown. It's really powerful, and it's a feature that's specific to Kubernetes. It doesn't exist for Yarn. There are two situations where this can occur. One is during dynamic downscaling, or the other one is if a spot kill happens or a preemption. So let's take the example of preemption just to explain. Amazon, when you're using a spot node and they decide they need to take the spot node away, they don't kill it immediately. They give you a 2-minute warning. And if you install a node termination handler, then you can listen to the warning from Amazon and tell Spark. And now with this feature, Spark is going to act on this warning. So what it's going to do is first, so it knows this node and this executor are going away. So it's going to stop scheduling new work on it. If there is a failure, it's also going to not count it as an internal failure, but as an external caused failure. And very importantly, it's going to move shuffle files, which we talked about, to other executors. That's very important because otherwise, when you lose the shuffle file, as I told you, you need to recompute the work. So you're losing potentially, hopefully, short work, but in the worst case, you could be losing an hour worth of CPU work if it's a shuffle file that took a long time to produce. So now you're going to be moving them to another executors who's staying around. And so when the node and the executor are gone, well, the Spark application can continue almost unimpacted because the shuffle files are still here, just in another executor. So basically, this is Kubernetes version of their external shuffle service. It's even more powerful because it handles spot kills, which is something you can't do with Yarn. And yeah, it only works with Spark 3.1. We've been testing it heavily, and it works well. It's not 100% of the scenarios that are covered, but it's 90% of the scenarios, and just that is great because basically you limit the impact of spot kills by 90%. I have one last, I think, example of a recent feature to share. It's basically the ability to mount a shared NFS volume. So before, there are different types of volumes you can mount in Spark. You can mount PVC. You can mount volumes I mentioned earlier, the local SSDs. NFS is a technology that was missing. What NFS is often used for is when you want to have a shared volume across all your Spark applications. So typically, you don't put your entire data sets in there because the bandwidth isn't that great. But you could put code, you could put libraries, you could put tiny data sets, you could put configurations. So that will simplify collaboration a lot. And now it's just a few lines of code to configure on your Spark application. This being said, the NFS server is still up for you to run. It's not running on Kubernetes. There may be a way to run it on Kubernetes, but in the cloud, people commonly use cloud services abstraction. I think Google Files or Amazon File Store. Each cloud provider has their own managed NFS, and that's very easy to set up. So with this, I think we covered what I wanted to cover, and we are actually decent on timing, so we have time for a few more questions.
Righty. Wow, I think that was very complete. How many slides did you have? I think that might be a record for the number of slides that have been used in a meetup. But there's a lot of stuff to get through there. Do you find that this is still, I mean, like you said, you've seen some different angles on there. What is it that you feel that data mechanics responds to, if you would say your defining characteristic as a company of what you're really, really doing better compared to the competition? And what's one thing that you're doing much, much better? And what's the one thing that you wish you could improve the most?
Yeah, so indeed, the only way to compete with the big guys is to focus on one thing and do it much better. And we target pretty technical users, data engineers who are comfortable building Docker images and seeing the benefits of containerization, and comfortable calling an API. And what we excel at is giving them a really good developer workflow where in a single command, they can build their Docker image, run it on the platform, where they get a very good monitoring dashboard, and where we automatically tune a bunch of configurations for them, like the container sizes, like the Spark configurations. And yeah, for the end user,
I think it's a great point. Like you said, for the end user, thinking about experience, there's a sort of an element of empathy there that like the way you're inside the mind of an engineer, as an engineer. So I think there's a strong connection there. In terms of what you would like to improve, if you had a wish list, I mean, there's a lot of stuff coming out. Like you said, there's going to be news coming out tomorrow. There are new things happening all the time. But what's the one thing you're like, if I had 20 more people on my team, or, something that I could, push a button and do something, what would it be?
Yeah, this is something we're going to do probably medium term. Have a built-in scheduler within the platform. Right now, we tell people, use Airflow, we have a connector, or maybe, use whatever. We have connectors for most schedulers, but it's not built in. And once you have a built-in scheduler, there are many optimizations you can build on top of that. For example, right now, people, they tell Airflow, you should run this pipeline at 3 a.m. every night, and you should run that other pipeline at 6 a.m. every night, and so on. And they don't really care that it's 3 a.m., 6 a.m. They just have an SLA. They just want the pipeline to be finished before that time. So I'd like to give them that API. Tell me when the pipeline needs to be run. And then me as a platform, I'm going to decide when there are spot nodes available, when there is capacity, or when it makes sense to make your pipeline more cost effective. And if for some reason you had a dependency, you couldn't run the pipeline because maybe some upstream task wasn't finished, then we're going to help you catch up and run the pipeline twice as fast to make sure the data is ready when it needs to. So I think Tim says smart batch pipeline scheduling. This is something that's on our roadmap, hopefully for the end of this year.
Okay. And just as a reminder, in case some people got here late as well, Data Mechanics is hiring. You can find the job advert on our Slack. I'm sure also on your LinkedIn, on your webpage. If folks are interested in that, or JY, if you want to leave a link here in the chat, you can do that too. I got a couple other questions. Do you know why, this is a bit of a silly question. Do you know why Spark SQL is not called Shark anymore?
No, I don't know. That's a good question.
More of like a trivia question than really like a technical one. Anyway, we're getting more good feedback in there. And let's see if we can think about anything else here. Okay, talking about do you in terms of being user friendly, the Spark API. What do you think that it makes that API so developer friendly comparing to other tools?
First, if we compare it to what existed before, like Hadoop, it was amazing because you had high level API, just like pandas, just like, oh, I want to compute this aggregate, and you do it in one line rather than having to think, how do I fit this into the MapReduce framework? So when I think of the future of Spark, I think more and more that the power of Spark is that it is a programming language, so it's really flexible. More flexible than pure SQL. You can be writing your own code. You can build in your own Python libraries and package it. And at the same time, it's abstract enough so that Spark can figure out how to run this in a really efficient way. So I think that's the power. And I think initially it was a lot about Scala, and in the recent years it's been all about Python, and there are many things to improve there. So typically making it easy to convert between a pandas data frame and a Python and a Spark data frame. So we have customers who do that. They do their data prep in Spark in a parallel way, and then they collect the data on the driver and they continue with just Python, and that works beautifully. So
Great. No, that's perfect. Good stuff. Well, we are literally just finishing in terms of the time that we normally have. As usual, we have someone who's lurking in the shadows, creating an artistic representation of what you've been doing. Gorka, if you can share our screen. So let's see. Let's take a look. Our graphic recorder, Angel, is always doing an amazing job. And Angel actually had to really multitask today because I had to ask him to do something else for our webpage. But I think it's still a very, very nice summary of the things that were talked about there. Amazing presentation. I mean, we have a lot of meetups, and you can tell that JY is an experienced speaker. Very well organized presentation. As you mentioned, the slides will be available in our Slack, as well as probably Twitter, other places where folks can find them. I think there's a really, really good explanation of looking at how we got to here, where data mechanics enters into the equation, the kind of problems that you're helping folks solve, both on the engineering side as well as thinking about customers. So I think that was a very, very good presentation. Just a quick reminder as well, in case anybody got here late, we do have an event, co-located event in KubeCon on May 3rd. Our call for papers is still open for end user talks. So JY, if you'd like to apply, that's more than available to you. And I don't really have too much else to say. If there's anything else you want to leave folks with about any updates, where they can find out more information about the stuff's going on for data mechanics.
I just want to thank you. The energy you put in this is amazing. The energy from the community, the Slack channel, the artwork. Sometimes when you rap, I found this amazing. And beyond this, I offer everyone to connect with me on LinkedIn. Ask me your stupid Spark on Kubernetes question, and if I have an easy answer, I'll do my best. And obviously, if you actually want to potentially start using Spark on Kubernetes in production for your company, then we work with a lot of startups and big companies who do that. So reach out. Yeah. Excellent.
Can't put it better than that. Thanks so much, JY. Looking forward to having you on another meetup in the future, or possibly in KubeCon. Who knows? So anyway, thank you, everybody, and we'll see you soon. Cheers.
Thank you.
Bye-bye. Bye-bye.